In this video, we will discuss the discriminant. The discriminant is a useful formula in determining the behavior of quadratic functions. Over the next several minutes, we'll discuss the standard form of a quadratic and the discriminant formula, results of the discriminant and what they tell us, and several examples to illustrate the point. Let's get started. Recall that the standard form of a quadratic is of the form ax squared plus bx plus c. The discriminant formula is of the form b squared minus 4ac. For example, if our standard form of a quadratic is 2x squared plus 3x minus 2, we can identify that a equals 2, b equals 3, and c equals negative 2. The discriminant of this example is the b value, 3, squared, minus 4 times our a value, 2, times our c value, negative 2. We get 9 minus 4 times 2 is 8, times 2 is 16. Negative times a negative gives us a positive value, so that's positive 16. 25 is our discriminant. There are three types of values the discriminant can take: positive values, negative values, and 0. These are the three types of numbers we must consider when looking at the number of solutions and type of solutions of our quadratic. If we get a positive result, we have two unique real solutions. If we get a negative result for our discriminant, we have two unique imaginary solutions. And lastly, if our discriminant is 0, we have one unique real solution. Let's go ahead and take a look at some examples to make this point crystal clear. For our first example, we have negative 2x squared minus 8x minus 14 equals negative 6. In order to set up our discriminant correctly, we have to bring all terms to one side of an equation. In this case, I'm going to add 6 to both sides, so I get negative 8 as my constant term equals 0. And I can identify a equals negative 2, b equals negative 8, c equals negative 8. Recalling my discriminant, b squared minus 4ac, I get negative 8 squared minus 4 times negative 2 times negative 8. So I get 64. 4 times 2 is 8. 8 times 8 is 64. Negative times a negative is a positive, times a negative is a negative. 64 minus 64 equals 0. If you recall, 0 implies that we have one unique real solution. In our next example, we have negative 7n squared plus 16n equals 8n. We'll go ahead and bring negative 8n to the left side of this equation, and we're left with negative 7n squared plus 8n equals 0. Our a value equals negative 7, the b value equals 8, and our c value, as there is no constant present, equals 0. Using our discriminant, b squared minus 4ac, we get 8 squared minus 4 times negative 7 times 0. This 0 cancels out our entire right expression, so it all equals 0, and we're just left with 64. 64 being a positive number indicates that we have, as a result, two unique real solutions. One final example before we wrap up. Let's consider the case of negative 10n squared minus 3n minus 9 equals negative 2n. As before, we're going to bring all of our terms to one side of the equal sign, in this case the left side, and we're left with negative 10n squared minus n minus 9 equals 0. In this case, a equals negative 10, b equals negative 1, and c equals negative 9. One more time, b squared minus 4ac is our discriminant, so we get negative 1 squared minus 4 times negative 10 times negative 9. This is 1, negative, positive, negative, so minus 40 times 9, which is 360. This leaves us with negative 359. A negative discriminant tells us that we are left with two unique imaginary solutions. If you have any questions or comments, feel free to leave a message in the comment section below. Please like and subscribe if you'd like to see more content like this, and as always, thanks for watching.